The James Webb Space Telescope has set a new record by observing a region of the universe when it was just 2% of its current age, simultaneously capturing the most ancient galaxies ever known. As the most powerful space telescope ever built, James Webb possesses unparalleled capabilities to observe the universe's most distant galaxies, akin to a time machine that transports us back into the past. In practice, it is evaluated to have performance 5 to 10 times superior to any other telescope in measuring distant galaxies. Now, less than a year after its launch and just 5 months since it was officially ready for scientific operations, the Webb telescope has been used to discover the most distant and ancient galaxies ever confirmed. Based on data from James Webb, an international team of astronomers has identified the 4 most ancient galaxies ever known to date. The light from these galaxies has traveled for over 13.4 billion years to reach us. They formed very early, when the universe was only about 400 million years old after the Big Bang, meaning at a time when the universe was only about 2% of its current age. Based on data from the previous Webb, potential candidates for early galaxies like these have been identified. These objectives have now been confirmed through the collection of spectral observational data, revealing the characteristic and distinct patterns in the light signatures emitted by these extremely faint galaxies. Astronomer Emma Curtis-Lake, a co-author of the study from the University of Hertfordshire, UK, stated, "The crucial point is to demonstrate that these galaxies truly existed in the early universe. This is because nearby galaxies could easily be mistaken for very distant ones. The observation that the spectrum was revealed exactly as expected confirmed that these galaxies truly exist at the edge of the universe, within our observable range. Some craters located farther than HAPBOR can also be observed. This is truly an extremely exciting achievement for the mission." The James Webb Telescope's ZAIDS Deep Extragalactic Survey. The focus is the space inside and around the deep field of the HAPBOR Space Telescope. From these images, the research team searched for faint galaxies that are only observable in infrared light. But their spectrum is abruptly cut off at a critical wavelength, known as the Lyman break. The NISPEC tool on the Webb then provides an accurate measurement of each galaxy's redshift. These observational results are the fruit of collaboration among pioneering scientists throughout the development process. The James Webb Telescope features 2 main instruments, the Near-Infrared Camera, CAM, and the Near-Infrared Spectrograph, SPEC. The study of the faintest and most ancient galaxies is the primary driving force behind the design concepts of these devices. In 2015, international teams of scientists jointly proposed the Enhanced Deep Galaxy Survey projects named James Webb and ZAIDS. An ambitious program was allocated over a month of the telescope's observing time, spanning a period of 2 years, and is designed to provide unprecedented views of the early universe, in both depth and detail. ZAIDS is an international collaboration project involving over 80 astronomers from 10 different countries. First observation cycle focused on the area within and around the Hubble Space Telescope. For over 2 decades, this small patch of sky has been the target of observation for most major telescopes, building a highly sensitive dataset covering the entire electronic spectrum. Now, the Webb telescope is offering a completely new perspective, delivering images that are both the most ethereal and the sharpest ever seen. This view, encompassing nearly 10,000 galaxies, is known as the Hubble Ultra Deep Field. The Hubble image includes galaxies of various ages, sizes, shapes, and colors. These smallest and reddest galaxies may be among the most distant ever known, existing when the universe was only about 800 million years old. About 1 billion years ago, when the universe was 13 billion years old, the nearest galaxies, which were larger, brighter, and had well-defined spiral or elliptical shapes, were undergoing a period of vigorous development. This image is the result of 800 exposures, taken over the course of 400 orbits of the Hubble Space Telescope around Earth. The total exposure time was 11.3 days, carried out between September 24, 2003, and January 16, 2004. The ZADESP program commenced with the NIA-CAM mission, utilizing over 10 days to observe a region of the sky across 9 different infrared bands, thereby producing exquisite and highly detailed images. This region covers an area 15 times larger than the deepest infrared image ever captured by the Hubble Space Telescope, while also being deeper and sharper at these same wavelengths. When viewed from a distance of 1.6 kilometers, this image appears no larger than a single person, yet in reality, it contains nearly 100,000 galaxies. Each star we observe is at a specific point in its own history, from billions of years ago. From these images, we can identify galaxies in the early universe by their recognizable signature, their unique multi-wavelength colors. As the universe expands, light is also stretched in wavelength. The light from these youngest galaxies has been stretched by a factor of up to 14. Astronomers are searching for faint galaxies, which can only be observed in infrared light, but their light is abruptly cut off at a specific wavelength. The position of the spectral line in each galaxy is redshifted due to the expansion of the universe. The GEODEST group has screened and analyzed images from OS to search for these special candidates. The universe is expanding, and this very expansion stretches light as it travels through space, creating a phenomenon known as cosmological redshift. The greater the redshift, the farther the light has traveled. Therefore, it is necessary to have a telescope equipped with an infrared detector to be able to see the light from the most distant galaxies. Astronomer Stefano Caniani, co-author of the study from the Subaerials Anomaly Research School in Italy, stated, "To date, these are the most impressive infrared spectral bands ever recorded. They revealed what we expected to see, a precise measurement of the cutoff wavelength due to heroic scattering between galaxies. 4 of the studied galaxies are exceptionally special, as they were determined to exist from an early period of the universe that we had never observed before. The spectroscopic analysis confirmed that these 4 galaxies are located at redshifts greater than 10, with 2 of the galaxies reaching a redshift of 13. This corresponds to the time when the universe was about 330 million years old, thereby setting a new record in the quest to find the most distant galaxies. These galaxies are extremely faint because they are located too far away from us. Now, thanks to the Webb telescope's exceptionally fine sensitivity, astronomers are able to explore their properties." Astronomer Sandro Tacchella from the University of Cambridge in the UK, a co-author of the study, explains, "It is difficult to truly understand galaxies without first grasping their earliest stages of development. Just as in humans, many later events depend on the influences from the first generation. Countless mysteries about galaxies are still waiting to be uncovered through the transformative power of the Webb telescope, and we are incredibly excited to contribute to this journey of decoding the universe's stories." Thank you all for watching this video.